Hello, pre-algebra students. It's now time for 2B.8, Chapter 2, the chapter that never ends, solving and graphing inequalities. And case 1, because there's actually a second case to this that we'll talk about next, not in today's lesson, in the next one. But this time, instead of me just giving you an inequality, a basic one, that the variable's already by itself, this time it's going to be in the form of a little equation. So sometimes you have to actually solve the inequality before you can graph it. You can't graph it until the variable's alone. So this is very, very similar to solving equations. You actually solve inequalities the same way you solve equations. It's just that at the end, you're going to have an inequality statement instead of an equal sign. So you have to graph the solutions because there's not just one. All right, so let's get to it. If this is just like solving an equation, then you get to draw your nice little lines again and keep change. And again, how this is different from your previous lesson, there's not an x by itself on one side and one number on the other. So we need to make it look like that. When we were solving a regular old addition equation like this, a one step, to get x by itself, we added 5, right? We're going to do the same thing. We're going to add 5 to each side. Negative 5 plus 5 are gone. You're left with x. Negative 3 plus 5 is 2. And because it was less than to start, it's going to be less than at the end. So that's it. That's how you solve an inequality. Really is just like solving an equation. Except now I know that x is less than 2. I need to graph that. Because if x is less than 2, x can be 1, 0. It can be all kinds of different numbers. So let's graph that. We'll draw our line. Just like before, whatever value the variable is being compared to, that's your center value. And we are going to put appropriate numbers on either side using equal increments. So I just used 1, 2, 3. If x is less than 2, it can't be 2, so that's an open circle. And less means shade to the left. All right, let's try another one. Maybe you want to try a couple and then press play after and see if you got it all right. That's always fun. This right here is a multiplication one step because that number is right next to the letter. To solve multiplication equations, you have to do division. You do the opposite operation. When you take 2.5 divided by 2.5, you get n, and don't put an equal sign there. I always want to do that. Now you just need to take 11.25 and divide it by 2.5, and you end up getting 4.5. Now, at this point, I need to drop down the symbol that I started with. N is greater than or equal to 4.5. I'm going to draw my line. In the center, I write the value that the variable is being compared to, and then choose something to count by. I'm going to count by a half this time, so that means before 4.5 I'd have 4, and to the right I'd have 5. You could put 3.5 and 5.5 if you wanted. It doesn't really matter, as long as you're counting by the same amount every time. If n is greater than or equal to 4.5, that means it can be 4.5, so I'm going to close that circle. And greater than means shade to the right, because 5 is greater than 4.5. Keep it going. Ooh, fractions. Now this isn't a fractional coefficient. This is a negative 1/5 being added to d. And to cancel out things that are being added, all you have to do is add the opposite. So I'm going to add a positive 1/5 because that cancels out a negative 1/5. D is left. And remember, when you're trying to add fractions, you need that common denominator, right? So I don't want to put the negative with the 5 because then my denominator is not common anymore. We'll put the negative with the numerator. Negative 4 plus 1 is negative 3. And then I bring over my denominator. It was greater than to start. It's still greater than. So my solution here is D is greater than negative 3/5. We need to graph that. We're going to put negative 3/5 down here. And it's a negative 3/5, so we're still going to keep it fifths when we're counting. And remember, on a number scale, to the left of negative 3 would be negative 4. To the right of negative 3 would be negative 2. So we just counted by a fifth. If D is greater than negative 3/5, it cannot be negative 3/5, so it's open. And we will shade to the right, because greater values are to the right. I have a feeling you're going to look up at the number line a lot. That's good. That's what it's there for. All right, letter D. We're just cruising along. Draw your line. This time the y is over here. That's okay. I want to get rid of this 4.8 that's being added to it. And to cancel that out, remember we'd add a negative 4.8. So over here, the 4.8s cancel out. Y is by itself. And on this other side, you have a negative 3.5 plus a negative 4.8. You're adding like signs, so you get to add the digits. So 3.5 plus 4.8, that gives you 8.3. And you keep the sign, so that means it's a negative 8.3. I'm going to bring down the symbol just as it appears. Now see how that variable's on the right? I don't like that. I want to write it on the left so that we don't make little mistakes when we're graphing. I'm still comparing those same two numbers, and I need it to be the same comparison. So in this, it's opened up to the y. I still need it to be opened up to the y. So when you give your answers, give them to me with the variable on the left, please. To the left, to the left. All right. Sorry, it's too early for songs. It's actually like 6 o'clock in the morning right now. Okay. I'm going to put my negative 8.3 in the center. And I think this time I'll just count by tenths. Remember, with negatives, the higher digits are left. So this would be negative 8.4. This would be negative 8.2. Be careful with that, again, because if you reverse them, your graph's going to be wrong. Greater than or equal to means close. Greater than means right. Done. All right, keep on going. With this, I'm kind of reviewing how to solve a bunch of different kinds of equations, too. If you're wondering why there are so many examples, that's why. X is being divided by 10. You want x by itself. To undo dividing by 10, you guessed it, I need to multiply by 10. So those 10s will cross cancel, because this is really like 10 over 1. X is alone. Negative 2 times 10 is negative 20, and I'm going to drop down my symbol. Again, I do not like it when x is on the right. So I'm going to write x on the left, and it's pointing at the x. I want to make sure it's still pointing at the x. Don't point at your x. That'd be embarrassing. But this x, that's okay. Put negative 20 in the center, and count by whatever you want. I'm just going to count by ones again. So if you're looking at the number line, negative 21 is to the left, negative 19 is to the right. If x is less than or equal to, that would mean closed, and less means left. As long as your variable's on the left, then you can use that. Okay, letter F. This time I'm moving past our 1 step, so we have a 2-step here. It's okay, I'm going to keep change, draw the line, change the sign. I want 3x by itself first, because that's how you solve a 2-step. You get the variable term alone first. To get rid of numbers that are being added, you add the opposite of them. So I'm going to add a positive 2, because minus 2 means that's a negative 2. Those are gone, 3x is left. And when you take a negative 11 plus 2, you subtract and take the sign of the greater. So 3x is less than negative 9. To finish solving that, you divide by 3. I have x on this side, negative 3 on this side. Bring your symbol down the way it was. Yay, x is on the left. We can leave it alone. To graph this, I'm going to put a negative 3 in the center. On the number line, negative 4 would be to the left, negative 2 would be to the right. If x is less than negative 3, it cannot be negative 3, so I need an open circle. It can only be values that are less than that. Even negative 3.1, negative 3.2, all those values in between, those are all the things x can be. X can't be b, though. It can only be x. Anyway, I'm going to draw the line. This is a 2-step. It has decimals. It'll be okay. I want 6y by itself first, so I need to add a negative 7.3. And when you do that, those cancel out, right? So 6y is left. On the other side, you need to take 25.3 plus negative 7.3, which is the same as 25.3 minus 7.3. So you should get 18 for that. To get rid of the 6 now being multiplied by the y, you divide by 6. On this side, you get y. On this side, you get 3. And I drop down the symbol just as it appeared. So the solution to this is y is less than or equal to 3. I'm going to draw my line. 3 goes in the center. And finally, it's a positive 3, so it's back to normal land. 2 is to the left. 4 is to the right. If y is less than or equal to 3, that means it can be 3, so I'm going to close that circle, and less means shade to the left. Move on over. We're almost there. There's not another page after this, so you don't have to go, ugh. I know, I feel the same way. So I want 7y by itself first. That means I need to get rid of this negative 12 that's being added. So I'm going to add a positive 12. I am left here with 7y. And on this side, negative 16 plus 12. That gives me negative 4. All right. I need to divide by 7. And y is left on this side, and I'm just going to leave this as -4/7. That's totally fine. I'm going to drop down my symbol the way it appears. You know how I feel about the variable being on the right, so let's write it on the left. I have y, I have -4/7. I still want it to be opened up to the y. So there's our solution. If you don't think that's the solution, or you're a little uncertain, then go ahead and plug in -4/7 up here, and you'll see that you get -16. It works, I promise. Okay, so to graph this, -4/7 would go in the center. Since we're dealing with negatives, I'd have -5/7 on the left and -3/7 on the right. So I'm just counting by a seventh, which is fine. Greater than or equal to means closed. And if y is greater, that means shade right. All right, we have arrived at the last problem for this lesson. Yay! Then I can go upstairs and make everybody's lunch. Except for my husband, he does his own. Add a -8. Because that's keep changing. I want p over 6 by itself first. You always get rid of whatever's added to the variable term first. So that means I should add a +8 to each side. -4 plus 8 is 4, and p over 6 is left. To get rid of dividing by 6, to undo that, we do the opposite and we'd multiply by 6. Both sides. So on this side it would cross cancel, and now you have p by itself. 4 times 6 is 24. And guess what? You're done. So this says that 24 is less than p. It would be a lot easier if the p was on the left, so I'm going to write it on the left. It's opened up to the p, so it still needs to be opened up to the p. So there's our answer for that one. Draw our line. 24 is in the center. It's a +24, yay. So that means I can put a 23 to the left and a 25 to the right. Greater than means it can't be 24. It can only be values that are greater. All right, you are done. See you later.